Jeff. Thank you, Brennan. Thanks everyone for coming. Thanks NSMeetup and Amazon for having me. So I previously did a talk on server-side Swift many months ago. I think it was almost a year ago. And I didn't want to just give the same talk. So I went through those slides, got all the latest stuff and to see what has changed and kind of updated it. And instead of, that one was a lot about gotchas with Linux, Swift Linux. This one is more about my own opinions of how you should get started. And those opinions are mostly based on the fact that you're probably all Cocoa developers. And so you have this view of the world and it's different than most web people's view of the world. So who am I? I am an iOS developer at Topology Eyewear. You should go to topologyeyewear.com and check out our app. It's on the store. It's awesome. A couple of my colleagues are here. So, so we have a lot of fun there. In a previous life, which ended about a month ago, I was a UX designer for 4 years at Riverbed, which you've never heard of, and don't worry about it. It's enterprise stuff. And then also Twitter, web, links, and then slides for this talk are at that bit.ly link. And then if you want to watch the previous talk on server-side Swift, the bottom link has that one. And some of the things in there are a little outdated, but those slides are a little more detailed than these ones are tonight. I do have one small tangent. You'll have to forgive me. But I'm leaving soon and getting rid of all of my stuff. And I'm at a Cocoa meetup where hopefully there's some people that actually like old Macs and stuff. And I'm trying to find some homes for these nice old classic Macs. So I have two top of the line. I have a titanium PowerBook and a 12-inch PowerBook G4. 12-inch PowerBook has an SSD, and I removed the optional drive for lightness. So two incredible machines. They need a home. I'll give them to you. Like I just don't want to sell them or put them in the junkyard because hopefully someone will actually like them. More strangely, I also have a working Next Cube. If anyone wants to go really old school. This is just so expensive to ship, it's not even worth selling. So if you have any interest in any old stuff, I have lots of old technology things that belong to this, and talk to me afterwards, and it's yours.
Wow. I'm there.
All right, end tangent.
First tips.
Okay.
Where are you moving?
Sorry?
Where are you moving?
I'm not moving. I'm leaving and doing a round the world trip.
Yay.
Nice.
Yeah. Yay. Vlog it. Or vlog it.
Yeah, we're going to have to do something like that. Okay, so how did I get these opinions? Like I said, most of them are kind of opinions shaped by my background learning to program with iOS. And so being kind of unfamiliar with a lot of how websites generally work and being more comfortable and more familiar with how iOS apps work and how they talk to web apps. Also, these are shaped by having built a simple web app with server-side Swift at my previous job. It was an internal app that we used for basic calendaring stuff. And at first we built it in Python because that was kind of the stack that most of my coworkers knew. And I disliked Python so much, I was like, F it, I'm just going to learn how to do Swift and on Linux, and I'll do it again so I can make it all nice and type safe and clean. And I also had to learn JavaScript, so sad face. But if you're making a website, you have to learn JavaScript, sorry. So what is the app? Who here works at like a big company or has worked at a big company? Okay, some hands. Who here has been in a meeting and the meeting went over, and then instead of everyone using that as like a really strong cue that it's time to just end this meeting, they said, no, we have to continue the meeting. And not only do we have to continue it, but someone else has this conference room right now and we're getting kicked out and we have to move to another conference room. So then everyone like picks up their laptop and they're like holding it like this, opening Outlook, like trying to find another room, just randomly picking rooms and then like looking in the calendar thing and like making sure the dates are right. It's like such a pain. So I built this little web app. It had to be a web app because we have lots of Android users and stuff. We weren't going to like, and it was internal. We're not going to put this on the App Store, do enterprise distribution for this, stupid little engineering app. And so it's for booking rooms for your meeting. And I called it Steel Reserve, and that's kind of an inside joke because at our company, all our products start with the word steel. And so we have like Steelhead, Steel Connect, Steel Fusion. And so it was really funny when I was able to get this one that's Steel Reserve, and it's malt liquor, and I got my designer coworker to copy the logo kind of to make this icon for the app. So you type in your single sign-on credentials and you can book a calendar or book a room really quickly. I'll show you how the whole app works. Now this started out as a storyboard prototype. So I don't know if you've ever used storyboards like this, but they're a really, really, really great way to prototype basic interactions for an app. So with like almost no code in any of this, you can click and go through to each screen and you can make a video and show someone, hey, this is how the app works. And you don't have to do any code or anything fancy, and you don't have to hope Framer.js matches the real animations of iOS. It's all in there. And that prototype looked like this. So you could book a room, choose how long you need it, which building it's in, and which floor, how many people you need to be in that room. And then basically at that point it was scheduled. That was how the prototype was supposed to work. Now I had to also make sure that I could actually do this, right? Because I'm dealing with Outlook here. And Exchange has what's called Exchange Web Services API. EWS, which is not AWS, totally different, and not nice. Every request is XML. This is a request to see when someone's available at a specific time, and that's not the whole thing. That's the request. All boilerplate. Thanks, Microsoft. XML. I think the things you actually have to change in here is like there's an email address and time 2 times, and all the rest is like the same. It's like what is wrong with this? That's actually how my previous company made all their money, is because we had a WAN optimization product, and so all we would do is strip out all this stuff and like reconstruct it on the other end because it's all boilerplate. So yeah, like I said, first written as a Python web app. We use CherryPy. So it turns out that most of these kind of web frameworks work pretty much the same conceptually, where you register, /hello will go to this function. And that's kind of how they work. So you say /index will go to this function, / this other endpoint will go to this function, and then the code just executes when you get called on that. And that's how the Swift ones work as well. So then I rewrote it in Swift and JavaScript in my spare time. Funny enough, since I don't work there anymore, I can't actually show you the app in person, but I still have the video of it working. So this was the real thing. This is just a Firefox window kind of shaped like an iPhone. So you log in, you choose how long you want the reservation to be, and click. And which building, and it checks all the rooms that are available. That's like 1 network request per room. So it's not a good idea to be doing this on the device, which is kind of why we wrote the web app. You pick your room, so Pacific, and now it's reserved. So much, much easier if any of you have done that in Outlook. And add a little email button that would pop up a pre-filled email with the reservation information, like super simple stuff. The only complex part was checking all the rooms. which was is one per room. So 30 to 40 network requests you had to do. Oops. So on to the opinions. Oh gosh, no. On to the opinions. Number one, I think server-side Swift has excellent tooling because you get to use Xcode for your development. And people make fun of Xcode and, oh, it's so bad and it crashes and this and that. But it's like, if you actually compare the tools that most web developers use when they're developing, they're usually just in like the terminal window, SSH'd into a thing and then print lining to debug. It's like a whole, I had a coworker, he was like, oh, I'm playing with Go now. The tooling is so good. Like when I compile, it tells me where I did something wrong and what line. I was like, wait, doesn't everything do that? Like, I don't understand how that's good tooling. So server-side Swift is awesome because you get full Xcode. You can set breakpoints, inspect memory, do all the same stuff you do with your iOS apps. And then obviously Swift is just great, has like the strong typing that we all like to protect ourselves with. I would say that server-side Swift has easier testing than iOS, and that's kind of two reasons. One, the Swift package manager just makes testing easier. You just say like SPM test or something, really, really simple. But the other thing is because there's no like fluffy UI kit messiness in your code, most of the time you're just outputting JSON. And so you can make a test that says, if I do this, does the JSON string match this string I have? And if it does, then it works. So it's really easy to do UI testing because you're not dealing with UIKit. So this is less than an opinion, I guess, more of what IBM is always pushing. IBM's pushing server-side Swift pretty hard, and in their presentations, they like to talk about how much lower memory Swift is than other competing ones. So poor Ruby. I don't know what's wrong with Ruby. But Node and Java both use still twice as much memory as Swift. And so I don't know what they're testing. Hopefully it's something like relatively normal. But that's important because when you look at doing some basic web hosting, like this is DigitalOcean. I don't know if you've set up a droplet with them, but it's awesome. It's so easy. But you can see that the main thing they charge for is memory. If you can run a super memory constrained 512 megabyte app, it's $5 a month. But if you need 8 gigabytes of memory, it's $80 a month. So lower memory is good. And I'm running the $5 droplet because I'm cheap. And I wasn't running a Swift app, but I was running, I won't say the name of the company, but I was running their service. And I didn't know this, but apparently DigitalOcean and most other of these Linux systems that you get out of the box have no swap. Like they turn that off. And DigitalOcean's like, oh, don't do that. It's bad for the SSDs. And it's like, well, I need my swap so I don't have to pay for more memory. So I just turned it back on because this server I was using was crashing. But if it could swap, it was fine. So sorry, guys. Next opinion, just pick, there's a couple different Swift server-side HTTP servers to pick from. Pick the one you like. Don't worry about it. Like, they're pretty much functionally equivalent. They might have slightly different twists on how they do JSON parsing and stuff, but they're pretty much the same. Just like I said, they're pretty much the same across different platforms. I chose Perfect. I liked it a lot. And the Perfect has a Slack, and they're super nice and super helpful. They're Canadian. So they help you do stuff, if you get stuck. I've also heard Vapor is good. And then IBM has one called Katura. I think it's interesting just because it's made by IBM. And I don't know if they're using it for customers yet, but the fact that they are pushing it and it's something they're interested in is interesting to me. So no matter which of those you choose, start with an app called Perfect Assistant, which is it's from the people at Perfect, but you can use it for any of those. It even has a built-in project template for Vapor, for instance. And it's a glorified wrapper around terminal commands. I hate the terminal. Every time I use the terminal, I'm like, this is not 1984 anymore. We've gotten past this. Why am I still doing this? I don't understand. And that's one of the reasons why I like iOS development so much, because Xcode does most of that for you most of the time. And so this thing is great. When I wrote the app, this wasn't available, but since then I've played around with it. And so I can definitely say, yeah, use this. It gets the dependencies, builds the Xcode projects, and it does Docker magic so that you can run your Linux apps in Linux and test them in Linux without having to deal with VMs and droplets and all that kind of stuff. And I just wanted to note here, builds the Xcode projects. This is the one major difference between iOS development and server Swift development. The Xcode project is like a throwaway item. So on iOS, we have all the build settings, and you like go through and you're like, oh God, I hope this build setting fixes my problem. And then you like change 10 build settings and you don't know which one fixed it. And you're like, I'm never touching that again. And if you lost that project file, you'd have to do that all over. With server Swift, you don't do that. The Xcode project is generated, and you need to do it fairly often, like when you add dependencies and stuff. So it's mostly best to consider the Xcode project as a throwaway item. Or else you'll end up putting settings in there, and then you'll lose them all when you need to rebuild it. So this is the site for Perfect Assistant. Let me give you a quick demo of how it works. So I've got it here. It's not as pretty as Xcode, but it does the job. So I've got my little Docker thingy up here. It warns you if you don't have Docker. But inside here, there's a bunch of app templates. So we can just choose the perfect one. And I'll give this a location. So there's this checkbox here. It says integrate Linux. I'll show you that later. Right now, I'm not going to do that. So we create this project. It does a lot of spinny stuff. See here. Generating the Xcode project. And hope I have backups in case something happens. There we go. Okay, great. So if we just look through here, we can see that it has one dependency, which is the HTTP server. That's like the minimum you need to get started with the perfect web server. But there's a whole bunch of other stuff in here. So if you want different SQL integrations, if you want ORM integrations, if you want XML parsing, curl stuff, like it's all broken up into these little micro frameworks. So it's kind of nice. It's all kind of in this one package. It won't have everything, but it'll get you started. Then there's commands in here to build. So build with Linux, build local, and then also, importantly, test. So you can run the tests on your Mac and run the tests in Linux from here. But what I'm going to do is I'm going to click open to open it in the directory. And I can drag this Xcode project into Xcode. And we can see here we've got a main. That's kind of the entry point. And we can see all the dependencies it got for us automatically from that perfect dependency. And then I'm going to click run here, and we're going to watch compiling code on stage. It's pretty fast to compile, and this is a MacBook Adorable, so it's not too bad. It's definitely better than if you have big Cocoa Pods or something. And considering that this is like compiling the equivalent of Foundation, right? Because it's the whole web server, all the stuff needed for your entire existence is compiling right now, whereas normally we don't have to do that because it comes pre-compiled on our systems.
How big is the resulting thing?
The binary? Yeah, I don't know. We can check afterwards. They're pretty small. So now we see HTTP server started, localhost. So I can go here, refresh. I'll scroll down to the bottom so you can see the routes I was talking about. Is this too small? Presentation. Okay. So there's the routes. This is where you say, I want / to call this handler. And this handler is this built-in function they have. But of course you can you can make your own objects, right? It's still an object-oriented system. You can do all the normal stuff you do in iOS. But this is just the simple way to get started. But I can do all the normal things we normally do. So I can say, let my variable, right? And then I can drop that into this HTML. And now rerun it. And in Safari, now I get the new string. You can also do, we'll just import foundation, right? And so you can do arc. Right, and then we'll get a random number on every refresh. And just to clarify one thing, I didn't quite fully grasp this until I was working on it, but this is like a program and it has its own state and the state is preserved. So I can, right here, I can say var my variable, what is this? Int 32, and I can say, if right, so now this is going to be nil. On the first refresh, it's going to get a number, but after that, that number will stay the same.
So,
yes.
So this is actually kind of a pain point in like earlier web frameworks. Like if anyone ever worked with like mod Perl or all kinds of things where you had like a state that kind of lingered after a request. So is there a way to kind of be request oriented and have things tear down?
Oh yeah,
and kind
of course. So
guarantee that you don't actually leak things.
Yeah. So don't use global variables. Programming tip 1 in iOS or web, don't use global variables. So yeah, all those things still apply. It's just like an iOS app. You want to make sure that when a new request comes in, you're constructing new, fresh objects, like if you have the performance for it, right? And then if you don't, then you try to cache things and then you get a big pile of mess. That's just programming. It's no different. I just wanted to clarify that you can do that. It's not a new program on every request, which is very powerful, right? So now it's 11. And if I restart it, then now it's 44. So just wanted to show that off. But yeah, you're totally right. You don't want to be storing things like that everything kind of mutates and then
It's kind of like a common pitfall in earlier web frameworks where you were in the same process and you were like littering over globals by mistake, not intentionally.
Mm-hmm, mm-hmm. Yeah, so it's kind of like putting everything in your app delegate. You don't want to do that. So back to slides. Oh yeah, and then the other thing, I just wanted to show, you set a breakpoint in Xcode, and then when you go into Safari, you refresh, and it exited code 0. I don't know why it's been doing that, but you refresh, and now you see Safari's like, oh my gosh, the request isn't coming back, and then you go in and look, wow, you're in the debugger. So you can look and you can PO my variable. And you still have the full debugging environment of Xcode, which is really, really nice. You can inspect inside the request that you got the type of method it was, the query string, cookies, all that kind of stuff is all exposed in the normal Xcode debugger that we're all really used to. And so this is really, really powerful compared to like print debugging.
How easy is to remote debug?
Well, so we'll get to that, but basically when you're debugging on Linux, you're on your own. Yeah. So it's only when you're on the Mac and you have Xcode that you can have this good debugging.
And yeah, the binary you're building now is an OS X binary,
Correct.
not a Linux.
Yeah, when you build it in Xcode there, it's an OS 10 binary using OS 10 Foundation, which we'll get to. Okay, so Linux Foundation is not always great. They did a good job. Like when Apple announced that Swift was going to be open sourced, all these web frameworks that were going after this started going then, and they didn't know that there would be any foundation at all. So they built a lot of stuff themselves to kind of assuming foundation wouldn't be there. But actually, Apple's foundation is pretty good. So like in my calendaring app, I did a lot of date parsing and stuff, a lot of date conversions and things, and all of that NS date components and NS calendar and that kind of stuff was all there. It wasn't always perfect, but it was all there. But the kind of annoying thing is not everything's there, and you don't know when you're running on your Mac because it's all there on your Mac. And so errors in Foundation will only show up when you're running or compiling on Linux, which can be a pain, but the Perfect Assistant helps with this, so I'm going to show that. Also, don't worry. It's not like Linux people haven't been able to do the things in Foundation for the past infinite number of years that Linux has been around, right? They all have those tools. So, for example, NSXML parser wasn't really implemented on Linux, and NSXML parser is terrible anyway. So in Perfect, they had a lightweight wrapper around libxml, which is like the Linux version of that, and it works fine. It's really easy. So that's what I used to do the XML parsing for Outlook stuff. So let me show you how that Linux integration works now with the Perfect Assistant, because it's much cooler. So I'm gonna make a new app template here, and we'll call this one Linux. And this time I am gonna check the checkbox. See, this is like an Apple demo. Just check the checkbox, builds for Intel. I don't know if anyone remembers that. So generating the Xcode project. Doing stuff. So this part using image, so that's the Docker image that Perfect has.
It starts with Linux in a
Yes. In Docker. Yeah, so not quite as heavy as a VM, but still pretty heavy. So that's done. I'm gonna open it up, open that in Xcode. And you can see we've got the same.
What's the difference between those two icons?
One's the framework and one's the app. So we got the same stuff, main here, compiling again. And we'll see that there's one last step in the compile, and it's a really, really, really good step. And I'll actually show it to you here while that's going. So in the app here under build phases, you'll see they've inserted a script, and it just says build Linux. And so this script basically reaches out to the Docker container, puts all the code there, compiles it, and feeds the compiler errors back into Xcode. So before, when you would compile on Linux, you just have to use the normal terminal window output Swift errors. But with this system, they actually go into the correct line in Xcode.
So you're building now from Mac? All
And-
this time was spent with building from Mac, although target is Linux?
So it's, I think I don't know exactly how much longer it takes. I'm assuming it takes about twice as long because it has to do twice as much work. So right now you can see this one-of-one shell scripts, and if I go in here, Docker is taking most of the processing power because it's compiling in Linux. But it still does the rebuilds really quickly. So now if I do the same thing, import foundation, and say, let my var equal arc for random, right? Now if I hit Command B, it goes into Linux, and then, oh no arc for random. So there you go. You get a much better warning about this doesn't work on Linux. It doesn't. I wish it actually told you in these errors like this came from Linux, because I was like, why is it giving me this error? I don't understand. This definitely exists, and then. But normally you wouldn't find out until you've been working for an hour and you got the whole thing working. You're like, oh, let me test it on Linux, and you go put it in. It's like, oh, there's no random. This will be hard.
So are you able to use available annotations to say, like, have
Yeah.
code that says, if I'm on Mac, compile it this way, if I'm on Linux, compile it this way? And then when you change the compile scheme, you can just see right away where the error is coming from?
So the question was, are there compiler directives like iOS versions? And there are. I can't remember what the syntax off the top of my head. That was one of my gotchas in my previous talk, like try not to do that, because then you can only test that code in Linux. But yeah, you can do that. You can say if OS, iOS, Mac OS, Watch OS, TV OS, do this, else do the other thing. Okay. So yeah, that is a huge thing. That wasn't available when I wrote the app. So Perfect Assistant, big thumbs up for the Docker integration there. Okay, next opinion. Force unwrapping on the server is in a completely different situation. So on a normal app, you say, oh, well, if that image isn't there, or this IB outlet isn't there, whatever, I'll just crash. It's no big deal. Like, that's not going to happen. But the thing is, that's only crashing for that one person. Like, if you have 1 million people using it, you would have to have 1 million crashes for it to crash for everybody. But with the server app, it's just one, and it's serving everybody. And yeah, you might have, some Kubernetes or something crazy to, make it redundant or whatever. But in general, you're going to crash for everybody if you force unwrap or do something else dangerous. So I think it changes the calculus quite a bit. I found myself saying, I don't care if anything goes wrong, I'll just output JSON that says like some unknown server error happened instead of crashing. And the only crashes I did were like if the things I needed on startup weren't there. So then I would know right away. This is my opinion, and different, if you're more experienced in web, you'll have your own opinions here. I think it's nice to treat the browser just like its own separate client. It's not part of your app. Your app takes JSON, returns JSON, and then JavaScript in the browser takes JSON and turns it into a web page and then sends JSON back to the server. And I think it keeps it easier to think about. It also makes it so that your code is not littered with stuff like this. Like multi-line string literals will help this a little bit, but it's not, you don't want that in your code. Like just HTML like that, not syntax highlighted, not anything. So leave the browser stuff to the browser and leave the server stuff to the server. And JSON parsing, obviously these web frameworks had to do it a lot because it was like, that's one of the main things. So they have pretty good ways. Perfect does it a lot like, it's just a dictionary string to any, and you kind of have to do some of the work on your own, but it's fairly simple. I think I have, a slide here. So like in that app, a page in JSON looked something like this, where I would have like the page title, the current step the user is on, and then names of the buildings and everything. And then I would just have nested dictionaries and arrays. It's still not great, but at least it's kind of strongly typed, and you just send that back out and then rely on the JavaScript to render it. Another thing, like if you look up, if you say like, oh, how do I create a JavaScript, like a modern JavaScript web app? It's like the scariest thing you've ever seen. Like you can find the GitHub pages where it's just like, oh, here's the 50 things you need to learn to do a JavaScript web app. And don't read into that stuff. Like if you're a pro JavaScript developer, React and Redux and Angular and Vue and all that stuff, those are awesome. When you're just a starting Swift iOS developer, they're not awesome because they're insanely complicated. It's kind of like if someone handed you the iOS SDK and said, okay, here's Reactive Cocoa, have fun. It's like, that's not how you start. JavaScript can be simple. You can build your own virtual DOM, which when I heard that with React, I was like, oh, wow, that sounds so fancy. And I thought it was like server stuff that happened and then transferred some crazy thing where the DOM was rendered on the server and sent over. No, it's nothing like that. All the virtual DOM is you construct all your HTML elements in memory, and then at the last second you stick them onto like the body of your HTML page. And React does a lot of stuff to like recycle them and be more efficient. But that's all it is just basic JavaScript. So sorry, this is a little bit small, but down here at the bottom you can see when you say create element div, like this is how you make HTML elements in JavaScript. And so this was a message object that I had in my code, and they displayed messages like in red or green at the top that say there were errors or you succeeded or whatever. And if you squint really hard, it kind of looks like Swift. And if you want your JavaScript to be type safe, you can just have functions that throw if it's not the type you were expecting. And this helped a lot in debugging. So I have these functions here, like Bootstrap was the CSS framework I used, which is super simple. And it only supports 4 types of these warnings. So I did a thing, like check to make sure it's one of these warnings or else crash. It happens at runtime instead of compile time, but you can check the types in JavaScript and do whatever you want. It's what happens when you don't check the types and then you get not a number all over your page. So that's not cool. Don't worry about RESTfulness. When you're just building a basic web app, like well-designed REST APIs are really, really good when you're Twitter and you don't know what a Twitter client looks like yet, and you want just to expose your database in a restricted way that is authenticated and rate limited. That's all great. REST APIs are not so great, and we've all had to do this when you have an iOS app and you have to make 4 requests to the REST API to get all the data you need, and then you have to do a bunch of processing on it before you can display it on the screen. You don't want to be doing that in iOS, and you don't want to do that in JavaScript. So just make the web app give you the data you need, and don't worry if it's technically correct or RESTful or whatever. Later, if it becomes a really big thing and you have to support random clients, then you can do a really good REST API.
What if you have an app that exists for a while? Mm-hmm. Then you kind of have to support, your random clients become your old versions.
That's true. So you, my thinking on the thing is, if your thing on your limited mobile cellular connectivity, be it an iOS app or a web page, is having to do multiple requests to your API to construct a page for the user, then maybe you need another server in the middle that can serve as kind of that buffer.
Oh, there are approaches to that.
Yeah. And I don't know too much about it, but Facebook's really been pushing the GraphQL system, and I think that's supposed to help with that, because you can say, I need all of this data, and then its job is to get that and return it to you. But right now, if you're just getting started with this, you probably won't be using that. Last one here is, I know this is kind of like our Apple thing is like we have to toe the party line and be like, take security seriously. But it is important. And, all the Android people and web people for so long have been able to like hold their openness over our head. Oh, our platform's open. It's like, well, we have security. So that's the one thing we got, damn it, and we're going to play it up. Be conscious with what you're doing with people's data. Like this app, Steel Reserve, was taking enterprise credentials. Not only did I only store them in memory, but I encrypted them and then stored the 2 keys in their cookies and then lost the keys. So even I couldn't get to them if the cookies were missing from their browser. I just considered them logged out. So you can do little things like that. Obviously, persistent storage is a tougher problem, right? Because if you don't want people to lose their data if they lose their cookies. But basically, be careful out there. You're not dealing with an iOS thing where by default their data is stored in this little pod that's encrypted already. And then we got a bonus because I said there were going to be 10, but this is the 11th. Make sure you have fun. We're all iOS, Cocoa, Mac developers. We want to use Swift and Objective-C to write all our stuff. This is much closer to that. It's not the same, but it's much closer to that than using Ruby or Python or whatever. And if you want to make a boring, reliable, normal web app, then use Ruby and Python. But if you just want to do it to have fun, then use Server Swift. And a shortcut I see here to more fun: skip the browser stuff. Yuck. No one likes JavaScript. Just build an iOS app that uses your server, and it's much more fun. So, thank you. Thank you all for coming. We have plenty of time for questions, and then afterwards I think is more beer and socializing. So, go for it. Yes.
When you look inside the Docker container that the Linux build goes into, is the Linux build one nice executable file that you can send to somebody and they can run it? Or is it a whole mess of special things and special locations that need to be there for it to work?
I didn't. So the question was, is the stuff that's put into the Docker container to compile really nice and contained, or is it all over? I don't know the answer to that. When I was doing it in a VM in Linux, doing it myself, it was you download the Swift compiler executable and put that somewhere. And then you run that executable against the Swift package file, and then it would put a bunch of stuff in that directory. So the Swift package file is this thing. So it would look in here, find out the dependencies, and then download them all into this packages folder. So it was relatively self-contained. And then when you actually compile in Linux, it builds a single executable, and then you can drag that around. I think its dependencies have to be in the same directory or something like that. But yeah, it was relatively self-contained. Yes.
So when you were building for Linux and setting all this stuff up,
Yeah.
And talking to XML, how many times did you have problems with Nokogiri?
With what?
Nokogiri,
I don't know what that is.
XML library for Ruby.
Oh, no.
So you didn't have any problems. That's good.
No, yeah.
That's the biggest selling point for me.
Yeah, there's no Ruby. I avoid everything that involves Ruby on my system unless it works with this built-in Ruby thing that comes in OS 10, because otherwise it's impossible. Declaring it here, Ruby is impossible. Yeah.
Just curious, how big was your app? What size was it?
Code or the binary?
Yeah, the binary.
Gosh, I have no idea. It was no more than 2 megabytes. Okay. Yeah, really small.
Is there forking, or how do you process more? How does it handle multiple clients? Is there any kind of auto restarting, pre-forking, threading? What's the model there?
So how does the web server handle multiple clients?
Yeah.
So I think they all do it differently. When I asked the perfect people, they said there's a set of listeners threads, and they are listening for requests, and then they will give you the request, and then you can either lock that thread until you give the response, in which case that listener is stuck there until you let go of it. But if you don't want to do that, the responses, they said, are thread safe. So you can jump off using Grand Central Dispatch onto another thread and release that worker thread to go do more requests. And then you can send the response on a different thread.
Mm-hmm. But if it crashes, it brings down.
So if it crashes, it crashes. You can do the equivalent of whatever Linux's launch D is to make sure that it relaunches if it crashes, I would assume. But yeah, when that was a big thing because I wasn't super familiar with all that stuff. So for my app, if it crashed, I would just let it crash and it wouldn't restart. And I'd have to go back in and hit the up arrow and hit return. Yes.
What was your load profile?
So it's this. So the question was, what was the load profile? I asked at work for the smallest VM they could give me. It had, I think, still a gig of RAM. It was not that lightweight, and it never used anything. They kept putting the thing to sleep. Because it wasn't doing anything, so they'd put it to sleep to save power. So I had to email someone to say hey, people are using this, don't put it to sleep. And so it was not used enough to push the system at all. And so I can't really say. And I didn't do any artificial kind of load tests on it. The main thing that would happen is actually Outlook would get mad and start returning errors for the API. The Outlook, as I was talking, my app was talking to our Outlook server.
Oh, okay.
Yeah, to get the data. So yeah, there is stuff for benchmarking out there, and you should try and find it because this app and in my stuff has never pushed anything to the limit. Yeah. Yes.
How do you serve static content? Is it
So there is. I have the actual code here. So they have a web root and an assets, and then that would get served up as the static directory.
Is that bundled in with the binary when you deploy it?
It's not in the binary, but it has to be next to it. And that's where all the
Mustache at all,
JavaScript.
or did you use Mustache, their implementation of Mustache?
No. So the question was, did I use Mustache? I believe Mustache is a templating system where you say, here's the content for this HTML page, and it sends it back. Like I said, I was just sending JSON across the wire, and then JavaScript would convert that into a web page. Yeah. Yes.
Is the testing story just unit tests, or can you exercise the whole HTTP stack through?
That's
the
a
built-in
good.
stuff?
So that's the question was, is the testing story kind of limited to your code, or can you fake HTTP requests and stuff? And so I don't know of anything out of the box to do that. Maybe someone has built that, but it uses XCTest. So yeah, it's much more friendly to unit testing, I guess, than for full continuous integration and performance testing. Yes.
Do you know if any of the other assistant apps are as slick as the perfect one? Because that one looks
Yeah,
pretty
isn't
cool.
that cool?
Man. I know, it's I don't need to know funny made up name for the library that does some incredibly common thing. It's just really obvious, oh, I need HTTP.
Yeah,
HTTP,
so the question was, do the other
Vapor
and Katura have something similar to Perfect Assistant? So I don't think Vapor does, but like I said, the Perfect one actually has a template in there for Vapor. Katura and Vapor. Oh, and Venice. So there's another one. So they have templates for the other guys. And I also think Katura has one because IBM has their own cloud service that they can deploy your Linux app to. And the Perfect Assistant helps with that too. I haven't explored it, but there's ways of getting your app into Google Cloud App Engine and AWS. So yeah, I think Katura has one. Well, any other questions?
Give Jeff a round of applause.